We're going to use what we learned from similar triangles to talk about a special part of mathematics called trigonometry. And what trigonometry is, TRI is the first three letters from trigonometry. And basically, what it is study of right triangles. And we're going to be looking at ratios still with right triangles. We're going to start off here talking about everyone's, I'm sure, favorite, the special right triangles that we had a few chapters ago. And so I have a 30, 60, 90 here on the left, 45, 45, 90 on the right. And these are what you're given on standardized tests and my tests and things like that. So it's not things that you have to remember. So the first thing that I want to talk about are these two items up here. This first one is called, or they're the same. They're equivalent meaning. The top one here is called SOHCAHTOA. And so if you can just say SOHCAHTOA to yourself and remember how to spell it correctly, you're going to get these ratios. Okay. And so this S represents sine, S-I-N-E. And what sine is, it's the name of a special ratio in a right triangle, which indicates that you are taking the opposite side over the hypotenuse. So those are another piece that you have to make sure that you understand is identifying the opposite and the hypotenuse in a right triangle. The C stands for cosine, and I have to write really small here because I didn't leave myself enough room. Cosine represents the adjacent side in a right triangle over the hypotenuse, and T stands for tangent, T-A-N-G-E-N-T, which represents the opposite over the adjacent. Now, I write it like this. Some students prefer this method rather than memorizing SOHCAHTOA, and I support you 100%. Okay, and so they just have the ratios written out, S and then over H, C, A over H, T, and then over A. You decide which works best for you. I just say SOHCAHTOA when I do it. Let's look at a few examples of this. Now, these trig ratios apply to acute angles in right triangles. So you got to make sure that you're talking about acute angles. And so I just happen to pick these special right triangles. They could be any right triangles. They don't have to be 30, 60, 90, or 45, 45, 90. These are just for examples. Okay, and so here's a 30, 60, 90 triangle on the left, and here's a larger one on the right. If I ask you to tell me what is the sine of 30 degrees, and notice the abbreviation for sine, S-I-N-C-O-S-T-A-N. If I ask you for the sine of 30 degrees, what you're doing is the opposite side over the hypotenuse. So here's 30 degrees. What is opposite of 30 degrees? Well, that would be the 1. And the hypotenuse is always opposite the right angle. So the answer to this question would be 1 over 2. We're going to quickly go through these, and we'll slow down and take more time in class to make sure that we get it. What's the cosine of 60? We'll go up here. Cosine is defined to be the adjacent side over the hypotenuse. So what is adjacent to 60? Well, that's this one right here. And the hypotenuse, well, that's still 2. So the cosine of 60 is 1 over 2. So yeah, the sine of 30 and cosine of 60 happen to give us the same answers. The tangent of 30 is defined to be the opposite side over the adjacent. Okay, so the tangent of 30, what's opposite of 30? That would be 1. What's adjacent? Well, it's not the hypotenuse, so it's got to be this one. So 1 over 3, if I simplified that, I would get square root 3 over 3. Okay, next triangle, the one on the right. Watch this. We're going to go pretty fast. Sine of 30, remember, opposite over hypotenuse. So that's 2 over 4, and that's equal to 1/2. The cosine of 60 is adjacent over hypotenuse. So the adjacent is 2 over 4, which equals to 1/2. And you may have noticed something that I'm going to comment on here in just a second. The tangent of 30 is equal to the opposite over the adjacent, which is 2 over 2 root 3, which is 1 over root 3. Simplify that. I get square root 3 over 3. And yeah, if you noticed, these ratios are the same. So in similar triangles, you get the same ratios. Why this is so important is because guess what, ladies and gentlemen? I don't have one with me. They're over on the side. But the calculators that you use do the same thing. Okay. So there's questions like this. I want you to know why the calculator is getting what its answer is. And then we're going to expand this to any acute angles. It doesn't have to be special right triangles like 30, 60, 90, and 45, 45, 90. Let's quickly run through a 45, 45, 91. And I'm going to keep these hidden, the SOHCAHTOA piece of it. Sine of 45, pick a 45-degree angle. We have 2 of them. I'm going to use this one right here. It is the opposite over the hypotenuse, so 1 over the square root of 2. I'm going to quickly simplify this. Cosine of 45 is equal to adjacent over hypotenuse. Tangent 45 is opposite over adjacent 1 over 1, which is 1. Okay, and now I just noticed my video cut out. So I'm going to stop right there.